Okay, this problem says a step-up transformer connected to a 110 volt line is used to supply hydrogen gas discharge tube with 5 kilovolt. The tube dissipates 75 watts of power. What is the ratio of the number of turns in the secondary windings to the number of turns in the primary windings? What are what are the RMS currents in the primary and the secondary windings? What is the effective resistance seen by the 110 volt source? Okay, so it's a step-up transformer. So here's a step picture for transformer. These are the primary windings, secondary windings, N2 and N1. So we have V1 over N1 equal to V2 over N2. And so V2 is equal to N2 over N1 times V1. Actually, what is it that we want? What is the ratio of the number of turns in the secondary windings to the number of turns in the primary winding? So we want N2 over N1. So actually, N2 over N1 is equal to V2 over V1, which is 5000 volts divided by 110 volts. So this is equal to 45.45, 45.5, which is equal to 46. Okay, so the ratio number of turns are 46. So the secondary coils have 46 times the number of windings of the primary coil. What are the RMS currents in the primary and secondary coils? So that's part A. Part B is what are the RMS currents? So these voltages are RMS voltages. The 110 volts is an RMS voltage. Okay, so of course power in is equal to power out. So VRMS times IRMS in equal to VRMS IRMS out. Okay, let's add a sheet page below. Okay, what is it that we're finding? What are the RMS currents in the primary and the secondary windings? Okay, in the secondary windings, they tell us the power dissipated is, power output is 75 watts, is that right? And 75 watts equal to VRMS IRMS. So IRMS is power, VRMS 75 watts, and the voltage was 5 kilovolts in the secondary coil. And this gives us a current of 15 into 10 minus 3 amps, 15 milliamps in the out. Okay. And now we'll use this to calculate the IRMS in. So the input current equal to power out divided by, okay, so that's 75 watts divided by input RMS is 110. So the input current is 0.68 amps. Okay. All right. And what is part C? What is the effective resistance seen by the 110 volt source? So, okay, let's add a page below. So you have at the input end you're providing 110 volts, and what you're doing is at the output end the current being drawn is 15 milliamps. I out is 15 milliamps. So this can be thought of as a black box, and this can be the effective resistance. Okay, so I out equal to V in divided by R effective. Okay, so V in is 110. Oops. So R effective is V in by out. And this is equal to 110 volts divided by 15 into 10 minus 3 amps. So what the input voltage sees, the effective resistance it sees is 110 divided by C is 7,333 ohms. Okay, that finishes this problem.